My name is Norm Johansson, a senior software developer at AWS, where I focus on all of our .NET tooling at AWS. And today, we're going to talk about .NET and AWS. Our main goals for today is to introduce our new .NET deployment tooling. Now, this tooling is meant to work with you. You can work it when you're creating new applications, some proof of concepts, and do simple deployments through Visual Studio or the command line, but also work with your applications that are more fully developed and you want to have automated deployments, more complex deployments. And we're also going to talk a little bit about the updates we have for .NET and Lambda as well. Now, our new deployment tooling is available in two different ways. The first is from the CLI. That is the .NET CLI, which you can easily install using the .NET tool command. Now, we're working very actively with this. We're doing new releases about once every 1 to 2 weeks. And it's all being done out there in GitHub. You can reach out on that GitHub repo out there and see the work we're doing, contribute, or also let us know what scenarios you would like us to help you with our new deployment tooling. The other way you can experience our new deployment tooling is with Visual Studio. There's a new integration with that. It's an opt-in preview. So as you're using the AWS token for Visual Studio, you'll see some of our existing wizards giving you an option to try out the new experience. So why did we build new deployment tooling? We already have the AWS token for Visual Studio, and it has several wizards already built into it for several AWS services in there. But with our new experience, we wanted to really make a unified deployment experience. We want you to think more about, here's my code, I just want this deployed to AWS, and not have to think about all of the different AWS services and how all those work. So we want to make sure you don't have to know a lot about AWS just to get started. But we also want to make sure that we don't hide any of the advanced features in AWS. All of the power of AWS is still available to you when using the new deployment experience. You can also get deployed to AWS in just a few steps. Now, a lot of the demos that you're going to see today is us using more of the interactive experience through the CLI or Visual Studio. And we want you to be able to reuse what you learned from there to actually create your automated deployments. You know, the thing that most of us want to get to for our production applications is to have it fully automated, and we want you to be able to use the new experience with that. Now, I know all of you have you work at companies and you have your own special rules and things you want to do when you do your deployments. So we also need to make sure that our new experience is extensible. You can add your own requirements into it, and we'll show you how you can do that today. Now, at a super high level architecture view of our application, the way we like to think about it is first we have what we call front ends. In this world, our front ends would be the .NET CLI or Visual Studio. Now, this is where your feedback comes in really handy of letting us know what other front ends you'd like. If you want Visual Studio Code or Writer, let us know it on our GitHub repos, and that helps prioritize our backlogs. Now, all of our front ends work with what we call our orchestrator. Now, you never work with that directly, but our front ends do, and it's what makes sure that no matter which front end you're using, you get the same features available to you. You get a similar experience matching the environment, and you have all the same features available to you. And that orchestrator, that's going to take care of working with all the other tools like the .NET CLI or Docker for building up your deployment bundles. And it's also going to set up your AWS infrastructure using CloudFormation and the AWS CDK. Now, if you haven't used the Cloud Development Kit we call CDK, that is a product that we have that essentially allows you to define your infrastructure as code. The way I like to think about it is essentially I'm going to write some .NET code, and when I logically compile it, instead of it creating a binary, it's going to actually compile into a CloudFormation template. That template can then be used to go create our CloudFormation stacks. And now that we're writing our infrastructure as code, we as developers can use all of the tricks that we know as developers to write reusable components. In CDK world, they call those components constructs. And the CDK team has already created a lot of these reusable constructs for us to use. So we can do within a few lines of code, what would normally take a lot of JSON or YAML to do if you were writing just the CloudFormation template. Now, for our demo application today, it's a really simple application we're talking about. This is an application that allows us to look up zip code information and provide that back to the user. But we're going to pretend, for the sake, that this is actually a much more sophisticated application, and it's being developed by multiple teams, and they all have their different requirements. So let's see what our teams are. The first is we've got Team Markers. Now, Team Markers is all about cutting-edge.NET. They're building the application using Blazor WebAssembly, which means the client application is going to go run inside the client's browsers. Now, Team Markers is going to rely on Team Stuffies. Team Stuffies is out there building a REST API, which is an ASP.NET Core 6 application, using a DynaDB table, which has all of our zip code information. Now, Team Stuffies is going to be relying on Team Dadrock to go and actually work with our third-party vendors who are sending us a CSV file to our S3 table and syncing that CSV file of all the zip code information into our DynaDB table. And so that we have a simple F# console application that we just want to run every once in a while to sync the data from our S3 bucket into our DynaDB table. Okay, so now let's go into our first demo. We're going to go look in how we're going to deploy our Blazor frontend. So let's go switch over to Visual Studio and see what that's like. Now here we are in Visual Studio. Now I did say we're imagining that this is 3 separate teams, but to keep the demo easier to do today, we're just going to actually have all the things in one solution so we can see the whole product together. In fact, I'm going to just go run F5 so we can see locally what this project is going to look like when we get it deployed. This is going to do a multi-launch where it's launching our REST API, you can see over here, and our Blazor application. And I can go in, I'll enter my zip code out here in Washington. You can see I live out here in Redmond, Washington, which is out here next to, Lake Squamish and Lake Washington, and all of the water that we have out here in Washington. Okay, so this is our application, and we can see here is our front-end application. It is a, like I said, Blazor application. What I want to do now is get this deployed to AWS. So what I can do now is I can just right-click on this and say Publish to AWS. Now this is showing the new feature that I've already opted in. So that's what you'll see for that. And that will start up our new deployment feature. Now our new tooling will basically say, oh, I see what you're doing here. You're trying to deploy a Blazor application. So it's going to tell you this is what we think you should do. In this case, we think you should deploy this to Amazon S3 and put a CloudFront distribution in front of that to expose your Blazor application to the public. And so at this point, I could really be done and say, yep, that's what I want to do. I can push publish and go ahead and get my application deployed out there. Now, I can also edit some of the settings. So we have some settings here, as well as some advanced settings as well. So this is mostly showing me some more settings for my CloudFront distribution, where, for example, I could adjust the price class to say, hey, I'm only going to be running this in North America and Europe today for my demo application. But when I'm happy, I can go ahead and push publish. And that's going to take care of everything. It's going to build our application using, again, the .NET CLI, but all this is taken care of for us by our tooling. And once that's done, it's going to start working on getting it deployed. Let's wait a second while that goes. All right, so now that got deployed or built, and now you can see in the log output that it's actually now working with the CDK. I mentioned that we use the CDK as sort of the engine to get your application deployed. I didn't actually, as the user, have to do anything with the CDK. It's just there in the background for us to take care of. We actually generate a CDK project, matching what your project needs, do the deployment, and then it goes away. It is just something that we use. So you can, if you don't care anything about the CDK in your pipeline, you can completely ignore it as just something in the log messages. But later, we will show you how you can actually customize a lot of the features of the CDK project. I know this will take a little bit to run, so let's go back to the slides while this is running. Okay, so let's see what we just learned there. Well, excuse me, but before we do that, this is what the deployment would have looked like if we would have stayed and watched the whole thing. We would see in Visual Studio that all got successful, and we'd actually see what our endpoint was to our application. We could click that link and see our application deployed out to AWS. Now, what we just saw here is we saw how we could do very easy deployments. Really, I could have just right-clicked, said, yep, I want to deploy it, and push publish. But we could see how we could also edit the changes and change things around. But it didn't take a lot of knowledge about AWS. Now, in this demo, we showed how we deployed our application from Visual Studio. In the next demo, we're going to show you how you can have a very similar experience using the .NET CLI. And we actually deployed a Blazor WebAssembly application. This is the first time we really had sort of first-class support for deploying Blazor WebAssemblies to AWS. And the way that we do that is we publish your application to Amazon S3, and then we put a CloudFront distribution in front of it to provide that public access to your Blazor application. Okay, so now that we have our front end out there, let's see how Team Stuffies is going to deploy out our REST API for team markers to use. So let's go switch back out to Visual Studio to see what that application looks like. So Team Stuffies is working with a .NET 6 REST API application. You can see here, this was they're working with their new minimal API style in .NET 6. Using in the DynaDB SDK to go pull in information and return those all out. Now I could go and just simply deploy that right here, same as we saw before, but this time let's take a look at what it'd be like to deploy from the command line. So to install the command line, we can just say .NET tool install -G for global deploy CLI. And AWS deploy CLI, that is the name of the NuGet package. And we're basically installing that NuGet package as a tool. Now, once we've done that, I'm going to get down into the project that we care about. And I can just say .NET AWS deploy. And that's going to go start off our deployment. Notice it's picking up my default profile and my US region. These are how I've set up my machine as its defaults. If I don't want the defaults on the command line, I can pass -- profile or -- region to override that information. Now I need to provide a name for my new CloudFormation stack. I'm just going to say push enter to use that one. And here we're getting our recommendations, similar to what we saw in the previous one. In this case, actually, we have two different options. We can deploy our ASP.NET Core application to Amazon ECS using Fargate, or we could deploy it to ASP.NET Core application to AWS App Runner, one of our new container services as well. But I'm going to stick with the default, and I'm going to go with ECS. And now you can kind of get the same thing. Now I can go change the settings. I could type more to see advanced. Once I'm done, just push enter and do the deployment. But this time we want to make things a little different because it's not just my infrastructure resources I want created. I want my application resources created as well. In this case, I have that DynaDB table, which is going to store all the zip code information. I want that created with my deployment. So what I want to use is I want to actually create a deployment project to customize the deployment. So I'm going to exit out of here. And let's see what that looks like. So to create a deployment project, I'd say .NET AWS deployment project, and I want to say generate. This is going to look at my project again and say, well, I can create a deployment project based off of these recommendations. And again, I'm going to stick with that default using Amazon ECS with Fargate. And now that has created a deployment project in my workspace. I'm going to go ahead and add that to my solution in Visual Studio so we can take a look. All right. So here's our project. And it is just a .NET project here. So the way that we've written these projects is all of the CDK code that really was part of that original recommendation that we selected is put in that generated folder, right? We can see in this recipe class, here's how we create the VPCs, the clusters, all that stuff is configured in here. And the intention is that you would probably leave the generated folder alone. It's there for you so you can learn how it works. And if you really want to, you can modify it. But the advantage of not modifying it is if we make changes to the original recommendation, you could just go ahead and put the new code over on top of the generated folder in your work deployment project. So where we actually would recommend if you want to make customizations is to start from the app stack. App stack class is really going to be like the root of the CloudFormation template. So we got a few things going on here initially. First, we grab the configuration object. This is where we get all of the settings that were made in the front end, whether that's the CLI or the Visual Studio. Then we're going to set a callback that's going to allow us to customize the resources that are created even as part of that recipe CS file. And we'll show that more in a second. And then we'll go ahead and start creating those resources with inside that recipe. Now to get started adding my DynaDB table, the first thing I need to do is add my a NuGet reference to my deployment project, to that CDK project. So I'm going to just go ahead, instead of using the NuGet wizard, I'm just going to go straight to the CSproj file and directly add my package reference into there. And you notice here I've got several CDK package references, and they're all of the same number. And this is what I would recommend you always do with the CDK, is to always keep the same version numbers used across all of your CDK packages. It's actually one of the things that they're improving in the upcoming V2 version of the CDK is the whole package management system. So you don't even have to worry about multiple packages and version numbers. And now that we have that, let's go back to our app stack. Let's add our using statement. And then I'm going to declare another member variable to represent our table here. So I'm going to call that read-only table zip code table. Okay. Now I'm gonna save you from watching me have to type a lot of code in here, and I'm going to go over to my cheat sheet here to paste in the CDK code for creating a table. So if we look at this code, and if you're unfamiliar with the CDK, it has the same pattern all over the place, where basically you always create a props object, in this case a table props object, set all of your properties on there, like our billing mode, our partition key, and then you pass that props object into the construct, in this case the table construct. And that takes in the container of the construct, a logical name, and all the settings there. And then we also set up a few indexes for searching by state or by city. So now, if I was to deploy my project, I would get my infrastructure code deployed as well as I would get now a DynaDB table set up as well. Now there's one more thing that we need to do. Because we have a table, we need to make sure that our container application actually knows what table to use. If we look at the code of our application, our REST API application, you can see at the very top here, we're looking for an environment variable that lets us know what table to use for our operations. So we need to set this environment variable in our container when we do deployment. And that's where that callback method comes into play. So we registered our callback method. That's down here. And this is going to get called as all of those resources are created within that recipe CS file. And in fact, the example put in our deployment project actually matches exactly what we need to do. So we get an event object, and that event tells us what is the logical name of the resource that's about to be created. Essentially, it's giving us like the props object is fully populated. We're about to pass it into the construct. And we can compare that to see, is it the one we care about? And the style that we wrote those is all of the logical name and the resources map the public property name on that construct. So I can still just do the name of property to give me some type safety on that comparison. So now I can just set that environment name to our table name. And so now when we do a deployment, we're going to get our infrastructure code set up, we're going to create our DynaDB table, and we're going to customize the container definition for our application to set the environment variable of the table that's going to have our information. All right, so let's see what that looks like. Let's go back to the command line and see what deployment looks like. I'm going to say .NET AWS deploy. I'm going to leave the default name again. And you can see now I have another option. My recommended option is to use the deployment project that we just created up there. So yeah, let's use that. And now we can go and make some settings here. For example, I need to give myself IAM permissions to my DynaDB table. So I'm going to go there, and I'm going to select my zip code demo table. And we can go into more, and we can see we've got settings for controlling our Fargate settings, basically how much compute power to put on there. Add some more security groups if we need to get access to things like our RDS databases. We can configure our load balancer, whether we want to create a new one or add ourselves to an existing load balancer, or we could actually turn on autoscaling. Actually, let's do that. Let's turn on autoscaling. So I'm going to say, let's change autoscaling. Let's enable it. I'm going to keep the minimum at 3. I'm going to say, let's let it grow up to 6. We'll scale up there. And instead of CPU, let's say that we'll set the metrics at memory. And if memory goes above 80%, let's do a scaling event. And I'll let the scaling cooldown stay at the defaults there. And that's it. So now with just that, we were able to customize our deployment. We were even able to add auto scaling and set up permissions. And I can just go and push enter. And that's going to take care of doing our deployment. Now you can see it's building up our Docker application. If I actually scroll back up though, there's an interesting line here. It generated a Docker file for us. My application hadn't actually been containerized yet for it. I had no Docker file for it. But the tooling is going to do its best attempt to try to make a Docker file for you. Now, your project might not match. It's going to have different requirements. So you might have to customize that Docker file, which has been written into your project folder. So this is, let's see how it's going. We're currently building up the Docker image up there for us. Let's see how that, all right, let's wait for that to go. We'll take a drink of water here. Okay, now with our Docker application built, you can see it actually logged into ECR, the AWS Docker registry, container registry that is, and it has now pushed our image up to there. With our image pushed, then you're going to see it's going to use the CDK project again that we just, but in this case, it's not going to generate one for us. it's actually going to use the deployment project that we created for it. Okay, there it goes. You can see it got finished pushing. And there we go. CDK is being used now as that vehicle to do the actual setting up of our infrastructure, including our DynamoDB table, which will be connected to our application. Okay, so while this is running, let's go back to slides. We can see this is what the output of what we just did deployment. If we watch that finish, we can see that we get sort of similar output we had in Visual Studio, where we can get our endpoints and other key information of the resources that were created. Now, what we just did in this demo is this time we did a deployment from the CLI. Pretty similar experience from Visual Studio, but it's a more command line based. Easy to install the CLI, just use the .NET tool command. In this case, our application was not container. We didn't have a Docker file or anything for that. So we let the new CLI tooling containerize our application. It looked at it, it saw what our class libraries are, and it generated a Docker file for us. Now, that Docker file is now part of my project. I can alter it and make adjustments to make sure it matches my needs. In this case, also, we wanted to create application resources along with our infrastructure resources as well. So we used a deployment project to be able to create our DynamoDB table with our infrastructure resources. Now, it's very important, though, when you use deployment projects to deploy to a CloudFormation stack, that you now treat this as part of your source control. It's what you check in and you reuse that to do your redeployments. Because that CloudFormation stack has basically been stamped with the ID of this deployment project. And so it's only going to be, be compatible with that deployment project with you. So now let's look at Team Dadrock, how Team Dadrock is going to get our data from S3 and into our DynamoDB table. So let's go back to Visual Studio. All right, so that is our project over here. This is our data loader. This is, in the case, an F# application that we've written here, which is essentially looking for a CSV file in a bucket, and going to go and actually fill in our DynamoDB table. So this one, I could go in and I could right-click and say Publish. And this is going to look to see, oh, this is not a web application like we've seen before. So I've got a couple different options, which is run this as a service. This is where you want to do something that runs indefinitely, like something processing messages from a queue or something like that. Or something that you want to just run on a schedule, which is actually what we want to do. Is like, imagine, let's just run this every night at midnight to go sync our table up. So I would want to do that one. But again, we want to customize our application because I could deploy this, but I need to communicate to the application what is the table that I actually want it to sync up with. So when I deploy it, I want to prompt the user to say what table to sync. So I'm going to create another deployment project. Right. Now, to create deployment projects right now, you do need to do that from the CLI. We don't yet have that support inside Visual Studio to create the deployment projects. So you do it from the CLI. So if I go there and I see that same command, .NET AWS deployment project generate. Now when we generate, we get those same options that we just saw, and I'm going to say I want to do a scheduled task. Now we've got that. Let's go ahead and add that project to Visual Studio. All right, so here's our project. Same pattern as we saw before. We have our generated section of all of the resources from the recipe, our app stack. But what we didn't talk about before is we also have this recipe file. Now this JSON file, this contains all of the metadata that drives our front-end experience. What are the settings? What are the names and all that set up here? For example, here's the name. Let's go ahead and change the name. Let's set the name to be scheduled task to sync table. Okay. And yeah, there's our description and short description. Your front ends can choose to use whichever one they want, depending on their UI space. I'm going to actually just set them both to my name here, just so we can just see that we've changed those up. Okay, we got our recommendation rules. These are the rules that essentially we run to see whether something is compatible, whether this recipe is compatible with your project. And then there's the list of all of our settings. And our settings have a lot of power on them of being hierarchical. You can have conditions on them, whether it shows up if other settings are set, validation on them. What I want to do is add a new setting here. I'm going to go again to my cheat sheet, and I'm going to copy over a new setting called the zip code table. And this is going to now present to the user a new setting to say, what is the zip code download table that we want to sync up? So if we look at what we have here, we have an ID, which obviously you can guess has to be unique for that setting. And then the name and the description is what's shown to the user. We specify the data type of this setting. We can also put a default value in there, and whether this shows up by default or only when you click the advanced settings, and also whether you can change this setting during a redeployment. So now that we have the setting in the recipe file, and our front ends will now prompt the user for this, we need to make our CDK code aware of this. So we take the idea of that, and if we look again, we can see we've got configurations over here in our generated folder. These are all partial classes, and we can also put our own configurations in the configuration that's not in the generated section. So I can say public string zip code. There. Now these projects are using the .NET feature nullability that's turned on by default. So that's why you can see I put the question mark there on the zip code table. So now that setting's in there, if we go back to our AppStack, this is where we grab those configurations. So we're going to get all the settings that were set in the UI, it's going to be passed into the configuration object. So if we go into our customization logic again, we can set that environment variable again. So we can go and turn that on. I need to add a using statement here. And let's see, let's go back to see, make sure I got the right environment variable that I need to set. Zip code. There's our zip code. And I'm going to set configuration zip code table. There we go. Now again, like I said, we've got nullability on turned on by default, so I do need to add that nullability check. So and configuration zip code is not equal to null. All right. So now what we've done here in our deployment project is, unlike the first or the previous demo where we actually created a table, in this case we've customized our deployment to prompt us to take in a table name for us to set. Okay, so let's actually deploy this now. Let's click on our application and publish that out. And we can see on our list here is our deployment project. And so this is again where you can see that customization comes in here is you can actually customize the UI experience inside Visual Studio, where you can add your own items in the list. We can actually edit the settings here, and we can see here is our new setting that we just set up. All right, so here is the table. I think, yep, that's the table that got created as part of Team Stuffy's deployment. I'm going to just go ahead and take that table name and put it there. And let's see here. I need to give myself some IAM permissions. So I'm going to actually not create a new role. I'm going to set a role here. Now, like I said, this is still in preview. This will be a drop-down box, but right now in the preview, that is just a text box. But it will be a drop-down box of all your existing roles. And then let's see, what else should we do here? I think I would like to see if we can get this to actually run while we're talking today. So instead of saying run this every hour, I'm going to say let's run it every minute, which I know is a bit ridiculous, but I want to see if I can get all three of our components running during our talk today. And with that, though, let's go ahead and push publish. So again, same similar things that we saw on the CLI, and that was sort of a goal, is to make sure that the experience from the Visual Studio and the CLI are both instructive, they're both interactive, give you a similar experience, and you can go back and forth between either one. So this is creating our Docker image out there, and it looks like we're going to now push that up to ECR, and now we're going to use our deployment project. Oh, nope, I got a little ahead of myself. Now we're pushing that up to ECR. And once that's done here in a moment, we should be now starting our CDK deployment. Now that we'll soon have this learning out there. So if we review, we'll have our 3 deployments down. We'll have our front end, our REST API, and our data loader. But the last thing that we have, though, is our front end doesn't actually know where to contact our REST API. What I mean by that, if we go back to the command line where we're doing a deployment, like we created this new API here, right? This is our API endpoint for our REST API, REST API, but our Blazor front-end application doesn't know about that. So we need to actually connect those up together. So I'm going to take that URL, and actually if we go back to our deployment of the front end, let's do a redeployment here. Here's our existing deployment. And I'm going to say edit the settings. There is another setting here if we can add a backend REST API. I can say enable that and paste in the URL. And I'm going to specify a resource path or pattern for this as well. Now what this means is when we do this deployment, it's going to add another origin to our CloudFront distribution. It's going to add this URL as an origin, and CloudFront is going to look at all the requests, and if the request matches this URI pattern, it'll send the request over to our REST API. And that happens to be how I implemented the REST API, is they all start with API. Any other requests will go back to the default distribution, which is our S3 bucket, holding our Blazor application. So let's go ahead and push publish. So we can republish our Blazor application and connect our backend API with our Blazor frontend. And this also is going to allow it so that we give basically a single endpoint to our users. Right? They're all going to be accessing everything from just the endpoint of the CloudFront distribution, and we're not going to have to worry about cores or anything like that for us to be able to connect those up. Okay, so while these 2 deployments are going for us, our data loader is running out there, and our redeployment of the front end connecting our back end, let's go back to the slides. What we just saw here, it was an example of how we can also deploy not just web applications. This was just a console application. With console applications, we have the options of deploying services, like long-lived services, something that's going to process messages from a queue, or we can do things as a scheduled task, which is what we wanted to do. We just wanted to run periodically and sync our CSV file up with our DynaDB table. And we did more customizations of our deployment project this time. This time we learned about the recipe file inside of our deployment project, which allowed us to add new UI settings. We basically customized what Visual Studio looks like with our deployment projects. We added a new setting, we connected that setting back to our CDK code, and was able to then connect it with our application. We also looked about how we can actually hook up REST APIs as sort of backend APIs for our Blazor application. So our Blazor application now knows where to actually go make its REST API calls. Now, so far, we've demoed all sort of interactive deployments, right, from the command line or Visual Studio, and that's really useful for, creating your proof of concepts or in your setting up your dev environments. But when it comes to your production environments, you more likely want to do an automated deployment, and the tooling can help you with that as well. you can turn off all the interactivity by passing in the --silent parameter. And all of the settings that we make inside the front ends can also be specified in a JSON file, which is now something you could use as part of your source control and see how the changes you've done over time. You use the apply parameter to tell it to use that JSON file for all of the settings you want to use for deployment. Now, I've actually set up a GitHub action out there that will show you how this can be done. So let's go switch over and see what that looks like. I have a repo out there on GitHub, which actually has a GitHub action set up using those same commands. We can see I've got, I'm installing my CLI tool. This is that convenience of the fact that the tool can be installed with just one single command. And then we run that, passing in that silent switch and our apply, passing in the JSON file of all of our settings. If I look at that settings file, I can see where it's specifying all of my settings and the stacks, region, everything that we need for this deployment. So now, while we're waiting for all of our deployments still to finish up the syncing of our DynaDB table and redeployment of our Blazor applications, let's talk a little about what's been going on with Lambda. It's something I'm always asked about is, what's the current status of .NET Lambda? So the first thing, and something that people are most excited about, is we have a new version of .NET this year. .NET 6 was released earlier this month, and that's an LTS version, which means that there is a managed runtime coming for Lambda. It's going to be out there for you to use soon, and there are two features that I think are particularly interesting for Lambda developers. .NET 6 really has a lot of great, exciting features, but these two features are things that you should pay attention to when you're starting to use Lambda in .NET 6, because they help improve your cold start performances, which is something we always want to improve with Lambda. The first is trimming. .NET 6 made it so you could actually trim your .NET assemblies to remove pieces of code that you're not actually using in your application. And this can dramatically shrink the size of your deployment bundles. And that helps you with the cold starts. Now, this does require additional testing, right? So if you turn this feature on in .NET 6, which is a feature you would turn on in your project file, you need to make sure you do extra testing on that to make sure that the .NET tools didn't remove any code that you were actually relying on. The other improvements, feature to look into, is the improvements to Ready to Run. Now, Ready to Run has actually been around for a few releases of .NET. But with Ready to Run, though, they made it so you could actually cross-compile your applications. What this means is, normally when you build your .NET assemblies, right, it compiles into a machine-agnostic instruction set, IL they call it, right? And then at runtime, your application is loaded up, and that IL is converted into native instruction set for whatever happens to be the compute environment you're running in. Ready to Run is where you actually say at compile time, say, I know I'm going to run on, in case of Lambda's case, a Linux x64. So compile it for that platform. And so you do all that runtime work at compile time, and that saves a lot in your cold start performance. Now, what they did in .NET 6 is they made it so that even when you're on Windows, you can use this feature. Because in previous versions of .NET, you would have to compile on Linux to make it run on Linux. But now, no matter what platform you are, you can cross-compile it for that. Lambda released this last fall ARM support, and this is a really interesting feature for us to use. It's using the AWS Graviton 2 processor, and it's a very easy way to reduce your cost. You get a 20% duration cost reduction when using ARM. It's right now supported in .NET Core 3.1, and when the .NET Core 6 runtime comes along, that'll be supported in there as well. Now, the programming model is exactly the same. Very few Lambda functions would actually need to have any changes done to them to switch over to ARM. But it does require you to recompile your application. When we create your deployment bundles with our AWS.NET tooling, we always try to optimize your package bundle specific for where you're going to run it. So we tell it, compile this and bundle this up for Linux x64. It gives you that smallest one. So now if you want to switch to ARM, you need to pass that ARM switch in there so that our tooling knows, okay, let's package this up and optimize it for ARM. Another thing I want to talk about Lambda is we have a new framework coming out, a new .NET Lambda framework. Now, with the .NET programming model, it's still basically the same, right? We have a function that you expose. It takes in an event object and a context object as well. And then you, from that point, write all the other boilerplate code that you would need to do from there to put your business logic in. We do also have that bridge library that allows you to run an ASP.NET Core application as a Lambda function. So with our new framework, what we're doing here is we're kind of trying to create something that looks similar to what you're used to with ASP.NET Core, but make it a lot more lightweight, and so it doesn't affect any of your cold start performance. So the experience will be a lot more idiomatic. You can use attributes and to say exactly where you're getting your data from, but it'll be with very little cold start times. And the way we're doing that is we're using a new .NET feature called source generators. So with a source generator, we actually generate all of the necessary boilerplate code that we would need for that idiomatic experience to bridge with the original Lambda programming model, all at compile time. And so you're going to get a lot of more idiomatic parameters into your Lambda functions. Dependency injection is going to be all set up very easily in this new framework as well. Now, since we're using the new source generator feature, this is a library that's going to be targeted for .NET 6. And we're doing all of this development of this new library, again, in the open. It's in our AWS Lambda.NET repo. We even have the design doc out there, too, if you'd like to take a look at that and provide your own comments. Let us know what features and scenarios you want to cover, or as well, you help contribute. Help us design the framework that fits your needs. Okay, so let's go take a quick look at what that framework looks like. Here is an example of how you would write a very simplistic Lambda function using the regular low-level style, where you take in your event object. In this case, this object is basically a Lambda calculator, right? We're grabbing the x and y's from the resource path, converting those to integers, adding them up, and returning them back. So a simplistic example, but you can see there's a fair amount of boilerplate code in there. And what we want as .NET devs is to write something more like public int add int x int y, right? That's really what we want to do, x plus y, right? Now, obviously, this is a super simplistic example, but we can kind of show you of this is where we want to remove the clutter in your application. So we can now do that with our new library if we add an attribute called Lambda function. And that's going to now identify this this function as a Lambda function. And our application has a reference to this new package called Lambda annotations, which includes our source generator, which is going to take care of making this attribute turn this function into an actual real Lambda function. And we can also specify we want this to be a REST. Okay, so we're going to say we're going to use a REST API. We want this to be a GET operation. I want to use the V2 format of the payload. And I want to say that this is going to be accessible with this resource path. Right? And if we do that, build that, that takes care of things. Because our source generator is going to kick in, and it's actually going to even update our CloudFormation template. There we go, just did. You can see here, it created our new resource, our CloudFormation template, and it put all our stuff in there. So as well as actually making it compatible with Lambda, it also keeps our CloudFormation template in sync as well. And you can see it has generated an interesting looking new handler string that actually is the undercover's generated code by the source generator that makes it map between that low-level Lambda programming model to what we just saw before. Now, another thing that I often hear when people are writing with Lambda is how can I get like dependency injection working in here? What is that experience like? And that's actually a first part with our new library as well. So in this case, let's say our very complicated business logic of doing add, we actually want to move that into our own calculator service. So let's do that. Let's create our calculator class. I'm going to go to my cheat sheet here a little bit and take the code here. And this is now going to define my calculator with its interface here, right? And so now we want to like register that with our dependency injection. So taking a cue from ASP.NET Core, we're going to have a startup class. Startup CS class. And here we can actually register things. Actually, I'm going to go back to my cheat sheet and take my startup class from there. And we can see we've got that same sort of configure services method, taking the service collection, and I can register my services in there. Now, this is the simple case, but you can register whatever services your application depends on. But notice we have this attribute here. So this is the attribute the source generators are going to look for to say, oh, we see in your application that you have an area where you're configuring your dependency injection, and we'll make sure that that's executed as part of setting up your Lambda function. So now, if I go back over here, I can actually use constructor injection, right? I can say public functions calculator. Go. Oh, I need to go make myself member variable, and then we can go ahead and use that here, x plus y. So there we can actually have it be injected into us as part of constructor injection. And when you do it as part of constructor injection, that means it's going to last for the lifetime of the Lambda compute environment. It works for those singleton injections. If you wanted a resource, or excuse me, a service that was working as more of a scoped one, where that resource was created from your dependency injection for every single request, I could do it in the actual method signature. I can say from services, and then pass it in through that way. So that's the other way you can inject your services into there. So now, if I compile that would actually deploy, and we would be able to, or that would build in our application. So we don't have time to actually deploy and see it, but let's take a look at the magic a bit under the covers of what just happened here. So if we go look at our actual DLL, this is the DLL that we just compiled here. And if we open that up into our favorite tool, there we go. We got our method right there. You can see we actually got a new class that was created from the source generators. You can see this is taking care of setting up our dependency injection. It's actually wrapping around our class that we just created for us. And then we're setting up doing all the marshalling of our resource parameters. So that's what we can do with it. Make it pretty simple. There's a lot of stuff happening under the covers. It's all happening at compile time, but we can actually now write code, very idiomatic .NET code here. Okay, so let's go back to our recap here. So the first main section we spent was on our new deployment tooling, which allowed us to create very simple deployments. I could easily right-click and deploy things, but we also used it to customize our deployments, add new resources, change the UI, make it as complicated as we need it to be for our specific situation. We also saw how we could automate our deployments for that as well. In fact, I think by now our deployments should be done. So why don't we go step back in the browser and see how things are working for us. Here is our deployed front end actually out there. Let's click on that. Yep, loading up our Blazor application. Let's see, we are going to be in Nevada, so let's look at Nevada zip codes. And yep, we must have got all of our data loaded into our table. Here is all of the zip codes for Nevada. And so just to confirm, if I look at my table, that it's been loaded up here. All right. So we saw the allows being deployed. We also spent a long time talking about .NET and Lambda. .NET 6 is coming. I know everyone is very excited about that. Definitely check out Lambda ARM. It's an easy way to reduce your costs. And we've got that new Lambda framework coming. We've been working on it very much. And you can definitely help us contribute to it, add new features, add new scenarios to it. And with that, thank you very much.